2014 AB problem 5. An unusual question. I'd never seen one like this in the history of the AP exam where they give you just a table like this. But it was a pretty cool one, and it still has the same ideas, testing the same ideas. So we're given two twice differentiable functions. This will tell you right away that the intermediate value theorem and mean value theorem are both going to be in effect. And here we are to interpret. For part A, find the x-coordinate of each relative minimum. That will occur when f prime changes from negative to positive. So if you just look at the table under f prime, you can see a change here at x equals 1, and there's your answer. For part B, explain why there must be a value c on that interval such that f double prime of c is 0. This is clearly a mean value theorem question. The reason being, you're not told anything about f double prime in the problem. You're told that, well, you're told information about f and f prime. F double prime is the derivative of f prime. So that means you're getting into the instantaneous rate of change of f prime having to be equal to the average rate of change of f prime on an interval. So clearly a mean value theorem question. Anytime you're answering one of those questions, you need to tie the differentiability and continuity of the function in question in so that you set the basis for the mean value theorem. Okay, for part C, the function h is defined by that. This is an embedded function, f inside of the natural log, and then they ask about h prime. This is just a clear signal for the chain rule. I look to the table for my answers. So f of 3 is 7. And f prime of 3 is a half, so for part D, evaluate this integral. This is an interesting question. So if you notice this, well, it's pretty ugly, but if you notice right away, it looks like a u substitution or chain rule type question, because if you set u equal to g, then du will be g prime of x dx. So I mean, that's what this question is about, but it's not the easiest thing to set it all up and write it correctly. So I would suggest in this case using an indefinite integral. Okay, you saw me stumble on this. This is a little bit difficult. Since you have an indefinite integral, you have to write plus c. I know in the problem I'm not going to be using that at all, so it really isn't important, but I don't want to write anything false, so I am going to write plus c. And in this particular problem, you can change the limits of integration if you choose to do it that way. It's pretty simple to just sub back in for u at this point. Now again, like I said, you have the plus c written, you're not going to use it, because what I need to do now is evaluate a definite integral. Okay, sorry. So again, the plus c's would just cancel anyway, so I'm not using them. Now here's not a final answer, you still have to put values in to get that. So it's a composite, you have to find g of 3 and then put that into f. So g of 3 is 1, f of 1 is 2. So that's going to be 2. Now g of negative 2 is negative 1, f of -1 is 8.